A rope around the earth, raised just 1 foot, made me wonder where else this shows up. In sports, on the playground, in the street, around the house. Once you see it, you'll start spotting it everywhere. Let's start from the beginning. Imagine a rope wrapped perfectly around the earth. Now, consider this. If we were to uniformly raise that entire rope just 1 foot off the ground, all the way around, how much additional rope would we need? Since the earth is huge, maybe a massive amount. On the other hand, it's only 1 foot, so maybe a tiny amount? Now consider a drastically different scale. If we were to do this with a soccer ball and raise the rope by 1 foot from its surface, how much additional rope do you think you need? Take a second to think. The answer, surprisingly, has nothing to do with the size of the object. To understand this, let's recall the fundamental formula for the circumference of a circle. C equals 2 times pi times r, where r represents the radius. So we use this formula for our initial scenario, where Earth's radius is r. Now, if we raise the rope so it is elevated 1 foot above the surface all the way around, the new radius becomes r plus 1. So the change in circumference depends entirely on the change of the radius. Increase the radius by 1 foot, the extra rope is 6.28 feet. Increase the radius by 2 feet, the extra rope is 12.57 feet. In this case, elevating the rope around the Earth by 1 foot will increase the rope needed by 6.28 feet. And returning to the soccer ball, the additional length required would be exactly the same, 6.28 feet. Did you imagine the result would be much different considering Earth being huge compared to a soccer ball? The size of the sphere might mislead us to think that a change depends on how big the object is, but really it only depends on how much we increase the radius. So as long as the rope stays 1 foot above the surface, the extra length is always the same, whether it's a planet, a ball, or even a penny. Now, that same small change looks very different depending on the size of the object. Considering Earth's circumference, adding 6.28 feet of rope enlarges the loop by only a tiny amount, essentially invisible. In contrast, for a soccer ball, the same 6.28 feet of extra rope increases the loop a huge amount, almost 4 times its original length. And this got me thinking. This principle shows up everywhere in the real world. Take track and field lanes, for example. The 2 curved ends of the track, combined, form a full circle. So, as each lane moves outward from the innermost lane, the radius increases. That's why starting positions are staggered, to compensate for the added length and ensure every athlete runs the same total distance. You can see the same idea on a playground spinning wheel. Kids sitting closer to the center barely move, while those seated just 1 foot farther out travel an extra 6.28 feet with every full rotation. Now think about a car making a turn. As it curves, the outer wheels follow a larger circle than the inner ones. That's why cars are built with a differential, a gear system that lets the wheels spin at different speeds so the car can turn smoothly. And a roll of toilet paper. The outer layers hold much more paper than the inner ones. Just the outer 30% of the roll can contain nearly half the total length. Pretty amazing, huh?